Assalamualaikum warahmatullahi wabarakatuh. Today we will present about cybersecurity in power system protection. As for introduction, my name is Rasha Dutta Afifah binti Muhammad Zamri. What is cybersecurity? Cybersecurity focus on protecting power grid and infrastructure from cyber threat to ensure secure and uninterrupted electricity delivery. It is also ensure reliable electricity delivery by protecting physical system, digital control, and network from cyber threat. SCADA system used across many industries for monitoring, control, and also automation. It will ensure safe and efficient operation in sectors like energy, water, agriculture, transport, healthcare, and also nuclear facilities. Tenaga Nasional Berhad, which is TNB, Malaysia's largest energy utility, also rely heavily on SCADA system to manage power generation, transmission, and also for distribution. Moving to table 1, SCADA cybersecurity incident. So previous study report indicate that there are more security incident and cyber attack targeting vital SCADA infrastructure. So due to the possible influence on the physical safety of worker, client or community, security issue for SCADA system are therefore becoming more important and significant than those for standard IT system. The repository of industrial security incident (RISI) contain record of 228 events documented between 1982 and 2014. So each entry include key information such as the year, title, industry sector, country, and detail about the incident and its impacts. RISI focus on monitoring cybersecurity events that affect SCADA system and industrial control processes. So this encompasses intentional incidents such as internal, external attack, denial of service attack, malware infection such as virus and worm, remote access breaches, and other cyber events impacting the operational environment.
Next, I will present problem statement. As power system become more digital, especially with the use of SCADA system, the risk of cyber attack has also increases. Originally, SCADA systems were designed to work in isolated environments, but now many of them are connected to large network and even more the internet. This makes them more exposed to and easier for hacker to attack it. There have already been real-world cases like Stuxnet worm flames. This cyber attack causes serious damage to equipment and even attack public safety. Many power protection systems still use old and weak security methods. These are not strong enough to deal with today's cyber threats. That's why it is important to study how cyber threats affect power system protection and find better way to protect the system. By improving cyber security, we can make our power infrastructure more reliable and secure.
Next, moving to methodology, SCADA system with main component. SCADA systems are vital for real-time monitoring and control industry like power and water treatment. They integrate hardware and software to collect, transmit, and analyze data from remote area devices. RTUs or PLCs collect sensor data and send it to a central SCADA host for processing and display via the HMI. Proper system design and configuration ensure efficient and reliable operation. SCADA system often control critical infrastructure, so strong cybersecurity is essential. Final testing and commissioning are required to ensure safe and correct system performances. Next, moving to SCADA system architecture. So for the first one, operator will monitor system status, respond to alarm, and perform control action either on-site or remotely. Meanwhile, for HMI, human-machine interface will display real-time data from the MTU and allow the operator to control processes through graphical screen. MTU, which is Master Terminal Unit, with central controller that collect data from RTUs and send command to ensure smooth operation. RTUs, which is Remote Terminal Unit, interface between field devices and the MTU, will gather sensor data and carry out control command. For PLCs and IEDs, PLC manage specific control tasks, meanwhile IEDs handle multiple functions and require simple setup. For sensor and actuator, sensor monitor value like temperature or pressure, meanwhile for actuator will carry out physical actions such as open valve. For communication protocol, the protocol like Modbus, HART, and Profibus ensure reliable communication between devices. Lastly, DCS integration Some systems use DCS for local processes control connected to SCADA for centralizing monitoring.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Asha binti Anwar and I will be presenting about IDS enabled SCADA for power system protection. What is IDS? IDS is intrusion detection system. It is a security tool that monitors network system for malicious activity or policy violation. The purpose of it is to detect and alert on threats like hackers, malware, or unauthorized access. It functions like a security camera for digital systems that watches suspicious behavior but doesn't block attacks. Why do we choose IDS for SCADA? For now, SCADA systems are now connected to a larger network, and then there are rising cyber attacks in Stuxnet, Ukraine, hack the threaten grid stability, and then traditional security is usually reactive, while IDS is proactive. There are three types of IDS in SCADA. First, a network base, second is a host base, and the third one is a hybrid IDS. Next, we will go to the case studies that we have in IDS. For the first case study is the substation IDS deployment. It occurred in the Southeast Asia. The attack detected is when unauthorized set point changes and communication exploits, and then it results on ATMS detection time, locked anomalies, login abnormal, and commands. And then for case 2, we have false data injection attacks, FDIA simulations. It targets voltage and frequency sensors. It misled control centers, causes wrong generation circuits detected by specification-based IDS. The detected by specification-based IDS, it detected 96% and latency 100 ms. It shows that data level protection is important, not just a network parameter. Next, we'll go on to the challenges that we have. For the first challenge that we have is the processing delay risk of IDS, because we need a fast response for it. Next, possible false alarm because it is too sensitive. Highly computational demands for ML models, and then requires trained staff to manage and update. We cannot hire beginners to use IDS because it is very crucial and sensitive. And then the key takeaways for IDS is that IDS strengthens SCADA against evolving cyber threats, and then the hybrid approach is the best for complex power systems. And then the real world case studies show that high success rates when using IDS. And then even though it has a successful rate, we still need a careful design, training, and system integration to have a better system protection in any country. That's all for me. Thank you.
Moving to the result and discussion of Technique 2, which is FDIA, I will start with FDIA threats in power systems. FDIA are highly sophisticated cyber threats that manipulate voltage or currents measurements in the communication layer of power systems. These falsify values, can mislead protection relays, and SCADA system, leading to false tripping or failure to isolate real faults. Traditional bad data detection methods are often ineffective as FDIA data is mathematically crafted to look legitimate. Moving to the problems found in the system. Firstly, insecure communication protocols. Protocols like IEC lack authentication, making it possible to forge control commands. Second, no real-time anomaly detection. Protection relays process data independently and do not recognize abnormal sequence. Third, over-reliance on sensor data. Systems assume all incoming data is accurate if it stays within the normal operating range. Lastly, the lack of redundancy. Systems with only one sensor are extremely vulnerable to single point manipulation. Next, move to the solution for FDIA problems. Firstly, IEC 62351 standard, which introduced encryption, digital signatures, and access control to secure substation communication. Secondly, defense in-depth strategy, which is combines multiple layers of protection including firewalls, IDS, secure firmware, and monitoring tools. Third, redundant sensing techniques, which is use of cross-verification and voting between sensors to detect discrepancies in data. And lastly, the solution is machine learning-based detection, which is algorithms like SVM, LSTM, and random forest can detect abnormal patterns beyond traditional methods. Moving to the deeper implication of FDIA. Firstly, protection systems must evolve to consider data integrity, not just electrical force. Second, existing hardware often cannot support advanced detection methods like a measure limitation. Third, those standards like ICE 62351 are sometimes seen as costly or complex. The long-term risk of inaction is far greater, including blackouts, penalties, and public safety risks. Lastly, the threat of FDIA is not just technical, it highlights a fundamental flaw in how trust is built into our protection architectures. Next, moving to the case study of FDIA, which is Ukraine 2015 cyber attack. Firstly, the attackers gain remote access to SCADA system. Hackers access Ukraine's power grid through SCADA system, showing how real systems can be controlled remotely during a cyber attack. Then, operator interfaces and firmware were disabled, which is the attackers made the system harder to recover by disabling operator screens and corrupting this device firmware. And false commands were used to open breakers, which is the attackers send unauthorized commands that open circuit breakers, causing blackout affecting over 200,000 people. This case proved that modern infrastructure is still vulnerable, even though Ukraine had updated technology. Weak cybersecurity controls made it easy for attackers to succeed.
Next, we move to conclusion. To conclude, the digitalization of power system, especially with the use of SCADA, has increases the risk of cyber attack. This trick can lead to serious issues like equipment damage, power outage, or even full system failure. In this study, we look at two main protection methods, which is intrusion detection system and FDIA mitigation strategies. Based on the analysis, IDS is currently the better option, so it is recommended to start with IDS for cybersecurity and slowly introduce FDIA technique in the future. That's all from me. Thank you.